So we are going to continue now with branches, and what we will learn in this lesson is how to create a branch, how to switch to it, how to merge branches, and how to delete references to branches. And then, very importantly, we are going to see how we can deal with merge conflicts when it comes to merging different branches. Now, how should you think of a branch? So it's nothing but a pointer to a commit, and then it's defined as all the points which are reachable from that commit graph. Sorry, all points that are reachable from the so-called tip of the branch. Usually when we refer to a branch in different commands, what we refer to is the tip of the branch. But when we think of it as branch, we think of all these different commits which are on the tip of the branch and the ancestors of it. Okay, so then the reference head is going to determine the branch that you are on, especially when head is pointing to the tip of a particular branch. So then why do we actually want to use branches? So it is useful because we may want to try different directions of the project. And let's say that we want to try to test an idea. We are unsure if we want to keep this in the main line of development for our code, but then we can create a branch and then introduce some ideas in that branch. And then if we like that line of development, then we can keep the branch. Otherwise, we can also abandon that idea altogether. So it's very useful if you always want to have one branch which is always like bug-free and is the main line of development for your repository, but then all other ideas can be incorporated in different branches. So then we mostly worked with one branch before, so think of it as one branch again as a line of commits. Then the head and the tip of the branch are just pointers to this latest commit. We'll see how we can actually add different branches, different lines of development in our repository. And we'll go a little bit fast here. So then one of the important commands is git branch, and then followed by a name. So in this case, cool feature. So in this case, what this command is going to do is to create a branch which is called cool feature on top of the commit that head is pointing to. So this new branch cool feature will be created from the current head. And this current head can be either the tip of another branch, but it can also be an older commit if we want to branch out from this older commit. We can move to, or so-called switch to another branch by either using git checkout followed by the branch name, or we can use the git switch command followed by the branch name. And then one important thing to know here is that when we do git checkout with a branch reference, then we move the head and we move the reference to the branch to this new so head is going to move, and then it's also going to have its associated new branch reference, and that is the name of the branch. So instead of creating a branch and switching to that into different commands, as we've seen, so git branch cool feature, git checkout cool feature, I can use one command that incorporates both of them, and that is git checkout with the option -b and then the name of the branch. So then it's like a combined command for this. We can list all branches that have been defined for the repository with the git branch command. So we've seen how we can create branches and switch to branches if we have two branches that we want to merge together. So let's say that we've been working on a particular feature for a while, and then we want to merge back into the master branch or a different branch. Then we use the git merge command, and the name of the branch we want to merge onto the present one. So here we were on the master branch, and then so we did a git checkout to the master branch. So we're on the master branch, and then we want to merge this cool feature branch onto the current one, so the master branch. And some best practices here when it comes to merging, it's the longer you wait with merging your branches, the higher the risk is that you're going to have a lot of conflicts that you need to resolve. So especially if you're working with many different people, consider merging every once in a while. Of course, if people are happy with the features that are introduced in the branches, because if it takes like years before branches are merged, then it's going to be really tricky to merge things back into the main one. Okay, so one can delete a reference to a branch by using the -d option. So this only means that the reference to the branch is deleted, but the commits actually do remain. So let's actually try this out in practice, and you may type along if you wish. You can also just watch it as a demo. That is fine, and I will do a bit of copy pasting here for the sake of time. So first, I'm going to create a project, and I'm going to create a directory, and I'm going to cd to that directory. It is called my project in this case. So I will first check that it's not initialized as the Git repository yet. So that is the output I expected. So this is not the Git repository. I can safely do a git init now and initialize it. So this is useful to do so that you don't by mistake try to create a repository within a repository. But Git is going to warn you anyway. So, but now I have initialized this directory, my project, as a Git repository. And then I will create a file. So this command patch is just going to create a file, and it's going to be empty. I'm going to stage it with git add. So git add file.txt. So now it's remember git status. I have one staged modification. In this case, this modification is just the creation of the file. So the file is empty. And I'm going to commit it. And then I have one branch here with one initial commit, one single commit as well. Now I'm going to create a new branch and switch to that branch. So I create the branch by using git branch cool feature. And then I can switch to that either using git checkout or git switch followed by the name of the branch. So git checkout to the feature in this case I chose. So now I see that, okay, I have switched to this branch cool feature. Let me do a git graph again. So then I see that, okay, I still have one commit, but then I have two branch references to this particular commit. It's both a cool feature and master. Okay. But then to see the branch I'm actually on, so I can do git status, and I see, okay, I am actually on the branch cool feature. So why do I want to check this? Because then, so what I actually want to see is the new commits I'm going to do, which branch will they be on? Will they be on cool feature or a master? They'll be on, obviously, on the branch that I'm on, and that is cool feature. Okay, so then let's actually edit this file txt. So echo this as a text is going to append this line to the file txt. So this is actually how it looks like. It has the content. This is a text. Going to stage this modification in the file txt. And then I'm going to commit this modification. So then what I have, let's do git graph again. I have a new commit on the cool feature branch that has this commit message, add the text to the first file. So then in the following, what I want to do is to go back to the master branch and do some changes there as well. So git checkout master, and then I'm going to edit the file and stage and commit these modifications. So stage this and commit. And then let's see again, git graph. So I had the initial commit, and then at this point, the branches diverged. So I have a master branch with this latest commit, and then I had the other cool feature branch with some modifications to that first file. And again, I mean, I use git graph, but it's just an alias to this command here. And the way you can do the alias is that way, if you have not done that already in the second lecture. Okay, so then what we want is to merge these two branches. And then before doing the merge, I actually want to know for sure that I am on the branch that I want to merge onto. And that is the case. I am on master, and what I want to do is to merge the cool feature one onto master. So I could have done git branch, for example, just to see, okay, I am on master, and then do git, merge the branch I want to merge onto this one. So, and the one branch I want to merge is cool feature. And then the merge is actually going to, the merge of two branches most usually is going to create a new commit. And I am prompted with a commit message. By default, it's going to have this first line here, merge branch, and the name of the branch you want to merge. But you can change that. But I'm happy with this commit message, so I'm just going to save that commit message file. Okay, so then it tells me that that actually it has used this so-called ORT strategy when it came to merging. This is just how, I mean, there are different strategies for merging, and they differ in the way that different changes in the branches are being incorporated. So but we don't have to go into great detail now. So usually the defaults that Git have are great. So how does actually our commit tree look like at this point? Git graph. In this alias I have for Git log. So I had these two branches, cool feature master, and they are now merged into this commit 84. So if I know that in the future I don't want to do, make any other commits on this cool feature branch, let's say that, okay, that has been a feature that I'm happy with. I don't need to work on that anymore. It has been now incorporated into the master branch. So I'm happy with all that line of development. I may remove the reference for this branch, and I can remove that reference with this command git branch follow, and the option -d, and the branch name as argument. So let's do that. So git branch -d and cool feature. And so I can remove this reference with the option -d if the branch has been merged. If the branch has not been merged, then I need to enforce that with -D. But yes, and what actually this will do is to remove that branch reference. So we don't have this cool feature anymore in our log, but the commits are still there. And why are they still there? Because these are commits that are reachable from the head. So remember that, I mean, the commit 84 actually has two parents. It has this commit 9f, but it also has the commit 69, which was on the previous cool feature branch. They are referable, they are reachable from this child commit. So they are staying in our log, and we can get that when we list all branches with git log. But the reference is dropped. So I don't have this additional reference to the latest commit on that particular branch. So that is gone. But the commits are still there, and we can refer to them, but only via the hash in this case. So this is more or less what we've done. We had some initial commit, did commits on different branches, and then merged. So then the default for branch merging is what actually I'm going to skip this to have some time. And focus mostly on explaining what fast forward merging is. So typically, when we merge two branches, so let's look at this example that we had it here before. So the cool feature and the master, then we are going to get a new commit that is going to incorporate the modifications from both branches. But then in the case that, for example, let's say we had the master branch, we had several commits on the master branch, but then we did some we created a new branch NAISS feature from this commit free, and then we did a couple of commits on this NAISS feature branch, additional commits, so the commit X and Y. But the master branch stayed unchanged to commit free. So there are no new commits on that master branch since we added the commits X and Y. Now, if we want to now merge master and NAISS feature, then because there are no other commits on the master branch from the point that the two branches diverged. Then when we do the merge, the only thing that will happen is that the head of the master branch is going to be moved to the tip of NAISS feature, and then but no new commit will be created because it's not needed as the NAISS feature and master branches had a common parent that was the tip of the master branch. So this is just a schematic illustration of what happens after the merge. So again, the tip of the master branch is just moved after the merge, and this is a fast forward merge, which is allowed simply because, again, we had no new commits on the master branch since the NAISS feature branch has been created. Okay, so now we have a few more minutes left, so then we can play with some more things when it comes to branches. So again, we can switch between different branches by using git checkout or git switch, if you remember. But then remember that if you have uncommitted changes, when you are trying to switch the branch, then what happens? So then the uncommitted changes are going to be carried to the new branch if that is possible. And then if you do a commit on the new branch, then obviously those changes will be committed to the newly switched branch. Now, if there is a conflict, so what the meaning that you have some changes in your working directory that are conflicting with the status of the file in the branch you're trying to switch to, then you will not be allowed to switch. So we've seen this example also when we try to do a git checkout. So you'll get an error, and then what you must do is either commit your changes or stash them away before you switch to the new branch. One note here is that, for example, if you have a new file which does not exist in the branch you're trying to switch to, then this switch is going to be allowed. And this is actually the example that we have here. So I have I am creating and switching to a cool feature branch. And then if I create a new file there and stage that, then I can actually check out to the master branch because the master branch does not have the new file before the switch. So there is no conflict. Now, if if it would have had a file that exists in both branches with different contents, then this switch is not allowed. So we go a bit fast here. So when it comes, remember that, okay, if you do have conflicts, you have some changes in, or you have some changes in your working directory that you cannot bring back you cannot bring to the new branch, then the best thing is to, well, commit them if you are ready, If not, then stash them away. Okay, so then this is just similar to what we learned in the previous lesson. So I will very quickly skip this. So if you do want to discard all the changes that you have in your working directory, and yeah, so you just want to get rid of those files, then you can do that with git clean, especially, I mean, for untracked and ignored files. So, okay, this we've seen. Actually, no, this is this we have not seen. So, okay, another possibility. So when you have a dirty working tree, meaning that, okay, you have modifications in your working directory, which you do want to keep, and actually you want to switch to a branch, but you also want to include the modifications that you have done in the working directory. If you just do git checkout branch, then you may have a conflict because of these modified changes, but adding the option merge, by adding the option merge, Git is going to try to incorporate all these different changes. So the change that you have on branch together with the branch that you have in the working tree. So and then what you are going to have after this checkout merge is so you will be on a new branch, and then the changes in your working tree will be incorporated on that branch. Okay, so then what happens if there are conflicts when we try to merge? So in many cases, Git is actually able to do merges without problems, but conflicts do happen, and that is in particular if you have modifications in the same lines in the same file in the same lines on the different branches that you want to merge. Then Git, so if when you try to merge these, then Git is going to complain about not being able to merge automatically, and then you will have to actually edit your files before you reattempt the merge. So let's go through one example here for when a conflict can happen. So then we'll do this quickly. So I will create a new repository for this. So you may notice that I exited the previous repository I was in. So I'm going to go into merge test and initialize this as a repository. I'm going to create a initial file and stage and commit this file. So then what I have is now one commit on the master branch. What I will do is create another branch and switch to that. So I use this combined command with -b, and then also change the file on this, change my file on this branch, and commit stage and commit this modification. Then what I have is feature 1 is ahead of the master branch with one commit. So now I will go back to the master branch and change the file, my file in that branch again as well, and commit that. But actually the change I'm doing is different. So let's do git graph again. So what I have is modifications in both the feature 1 and master branch since they diverged from this commit, from this ancestor commit 41. Okay, so now I can see how those two, how my file txt differs in those different branches. So I can do git diff for that, and I see that okay, the difference is actually in this second line. One of the the branches, the master one has this line working on a yes, the master branch has this additional line working on a really cool feature, but then the feature 1 branch actually has a different line as a second line. So when I attempt to merge these two, then I'm going to get a conflict because the same line has been modified in different branches. So Git will not know, okay, what line do you actually want to keep? I cannot fix this merge automatically. So I could have seen the content of these files again with git show, let's see, master file, my file txt. And similarly on the other branch, feature 1. So this, using git show may be easier to check the content of these different files if you find the git diff a bit hard to understand. So we'll just take 1 more minute and then we are done. So then what I will attempt is to do the merge of feature 1 branch into the master one. So I'm going to first check that I'm on the master branch. I'll do that with git branch, for example. Yes, I'm on the master branch. So then let's try to merge feature 1. So then Git tells me, okay, I cannot merge this automatically. There is a conflict, and the conflict is in my file txt. So then what I should do is to fix these conflicts and then commit the result. So if I do git status, what do I see? It's actually, I have modifications here. And why are they? Because, I mean, obviously I had not edited the file before I did the other commits. So what happened is that when I attempt to do the merge, then Git is going to try to incorporate these changes from these different commits in my file txt. Now, because it could not resolve the merge automatically, then it kept whatever attempt to incorporate the modifications, but it did not do a new commit. So if I do git graph again, I see that I am at the same stage when it comes to the commit tree as before the attempted merge. But the working tree is modified because Git did try to merge these different branches. So what I should do next is to check the file and try to, well, resolve this conflict on my own. So what Git did was to add these delimiters in the file. So it added a delimiter. So first the head that so the master branch has the head has been pointing to the master branch, so then it has used the head reference here. But then I also have some lines which incorporate the content of my file txt, which has been different on the feature one branch. And this is this line here. So when I resolve this conflict, what I should do is, well, first remove these delimiters and then decide on what I actually want to keep. And I may choose to keep both. I may choose to keep either of them. I may choose to have something completely different. So let's assume that I just want to keep all of them. Again, this conflict arose because I had the same line modified in both branches. Now, if I do git status, what I have is, well, the same information. I have this modified file. Now, if before I attempt to continue this merge, I have to stage the modification that I have done. So remember, I have edited my file txt with a version that I am happy with. So I'm staging this, and then what I do to continue the merge is I use the command git merge -- continue. So then Git knows that what I am trying to do is to actually continue this merge I had before. Where is it? Here. So Git knows that this is the merge I'm attempting, the one that I had a conflict for. So I get prompted with the commit message. I'm happy with that message. So now the merge is successful. I can do a git graph and see that, okay, I have this merged commit with the content. So let's see, what was the content now of my file, git show. My file, txt, these combined lines that I chose to have in this merge commit. Okay, so sorry for taking over time. So I will just add that if you do not want to, if you get into a conflict and you are not sure how you should solve it, maybe you want to talk to your colleagues and see, oh, you added this implementation and I had added something else, and then, I mean, which one we should actually keep, how should we resolve this merging, then you can abort the merge with this option here. And I think actually here it should be -- abort. It took one as it's bolded. So yeah, especially useful if you are unsure how you can resolve this conflict. Otherwise, you just resolve the conflicts on your own and then use git merge continue. So this is more or less it for today. Tomorrow we'll be doing some really fun things with branches, and that is rebasing and cherry picking. You heard some options with rebasing from Pedro. We'll learn some new things, and then we'll be doing exercises for branches in the first hour of tomorrow. And again, sorry that this has taken overtime. I was not anticipating that the exercise will take so long to record. Something to keep in mind. And any final questions?